So I'm going to take you through the steps that you need to do in SAGA-GIS to calculate the overland flow distance to the point of impact. So this is one of the data layers that you need for SCIMAP-Flood. So within SCIMAP-Flood we normally set up a number of different points of impact across the catchment, and we're then trying to balance the travel times to those different points of impact so we don't put in a mitigation feature which slows and stores water and moves that water out of a rising limb and into the peak part of the hydrograph. In terms of the steps for this, we're going to take the DEM. We are then going to pre-process it to remove the pits and the sinks within this surface. After that, we're going to look at the flow accumulation, change that to look at just where we've got the channels within the DEM, and then calculate the overland flow distance. And finally, we can then export it out as a data set to use within SCIMAP-Flood. So here we've got the DEM. The first thing we need to do is go into terrain analysis and then pre-processing, and then we go to sink removal. Here we've put in our grid system, our DEM, and then where we're going to put our pre-processed DEM. So we're going to put it back in on top of the main DEM. We're going to use the deepen drainage routes option rather than the fill sinks, and we can click OK there. Now the reason that we use the deepen drainage routes option is because that makes less geomorphic change to the surface. The more traditional fill type methods end up creating very large amounts of change, effectively making large lakes behind any kind of blockage within the DEM. The deepen drainage routes lowers the dam, breaks through the water that way, and actually changes the DEM less, and actually then gives let's change the surface and keeps the detail in that we're going to be needing later. Now this is going to take a few minutes to run through, so we'll just let that run through, and then we'll pick up the output and move on to the flow accumulation in the next step. Okay, so now it's finished. We can go and click on data, and here you can see it's changed to being pre-processed DEM. If we put that into a map, it's going to look pretty much the same, because the changes made are fairly small. So we're going to tools next, and then we can do go into hydrology, and then we want flow accumulation. So flow accumulation top down. So here we're going to put in the grid system, our pre-processed DEM as our elevation. I'm going to use the multiple flow direction algorithm, and we're going to make it go to linear flow above a certain threshold. So once we get things that are channelized, we don't want those kind of spreading out across the floodplain. We want to keep it in one channel. So we can leave that on the default of 500, and then our flow accumulation output we're going to put down to create. So click OK. That will run through, and that will give us our flow accumulation grid. Again, this takes a few minutes to run through, so we'll just let that kind of run through the processing now. Okay, so now that the flow accumulation is finished, we can open that map up. And here we can see our flow accumulation. So now the flow accumulation has finished. So now the flow accumulation is finished, we can open up that map, open that into a new map, and if I zoom in here, you can see how the channels have been identified and shown on the screen here. As part of the data set, I've got one impact point. So if I add that onto the same map, and just zoom out and then zoom back into that point, we can see that the impact point relates to this main channel here. Now what I need to do is go through and reclassify the flow accumulation so that we only have one value related to the input point which represents the channel, and the rest of it we need to create to no data. So if we look at the specification of that grid, of the flow accumulation grid, we can see that the no data value is minus 99,999, And the other thing that we want to know is our maximum value here. So here we can see it ranges from 1 to 1.4 million. So we'll remember 1.4 million. So if we go to Tools, and then Grid Tools, and then Change Grid Values Interactive. So we're going to do our flow accumulation. We're going to set one value to -1, click OK, click the pointer, and then we can set one point here to equal to -1. So we've got a little channel here, we've got the values of -1, that's going to be our channel outlet. So double click here to stop that tool, click OK. Now we go to Data, so we'll go stay in Tools, go to Change Grid Values, and then we're going to have Flow Accumulation, Change Grid, we're going to create, we're going to have a range, and here we're going to create a table. So our new value is going to be the minus 99,999, and we're going to change everything from 0 to the maximum there, and make all of that no data. So we'd just be left with two cells which will have a value of -1. So click OK there, click OK there. That runs through very quickly. So if we go to our data, we can see we've got flow accumulation change grid, which mainly looks white because most of it's no data apart from those two cells. If we go back to Tools, and then in the Train Analysis Channels, we then go to Overland Flow Distance to the channel network. We put in our DEM. Our channel network is then our flow accumulation change that we just calculated. Everything else we can leave as on the default because we want to create the overland flow distance. Click OK. That runs through. That takes a few minutes to run through. Then after that we'll have our overland flow distances to the channel. Okay, so that's finished. So we go to Data, then we've got Overland Flow Distance, double click there, put that into the map, and there you can see we've got our distances to that point of impact. So areas with red have longer distances, areas to blue have shorter distances. So what SCIMAP-Flood will then do is take this when it's imported, calculate the mean value of this for the central point, which is the water most likely to be contributing to the flood peak, and rescale this on either side. So we want to export this out, so we can right click, do Save As, so don't do Save Image As, do Save As, and then we can save it out as GeoTIFF. Alternatively, if you go to Tools, Import Export, and Export Grids here, we can then go through and export it out as an ArcASCII grid. So export Esri ArcInfo grid. So there you can put it out as an ASCII file. So select the grid system, select the grid, which is overland flow distance, save it to ASCII. Keeping the precision to 4 decimal places makes sense. Click OK. That will then be saved out, and that can then be imported into SCIMAP-Flood application. So I hope that overview has been helpful of how to generate the point of impacts. Normally for SCIMAP-Flood you'd go through and have multiple points of impacts across the catchment, but that depends on the catchment that you're working on. If there is only one point of impact, then just use that one location. If you need to balance between multiple points of impact, then you can put in a whole set of different ones.